बिस्मिल्लाहिर्रहमानिर्रहीम रब्बिश्रह सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Assalamu alaikum. Today we are going to study displacement time graphs. Displacement time graphs. We can represent the changing position of a moving object by drawing a displacement time graph. The gradient slope of the graph is equal to its velocity, figure 1.9. The steeper the slope, the greater the velocity. A graph like this can also tell us if the object is moving forward or backwards. If the gradient is negative, the object's velocity is negative, it is moving backwards. In figure 1.9, we are going to study displacement time graph. S is equal to displacement, T is equal to time. The gradient will give us the velocity. If the line is straight, it means that there is constant gradient and constant velocity. The straight line shows that the object's velocity is constant. The slope shows which object is moving faster. The steeper the slope, the greater the velocity. The steeper the slope, the higher will be the gradient and higher will be the velocity. The slope of this graph is 0, the displacement s is not changing, hence the velocity is equal to 0, the object is stationary. S is the displacement. If the displacement remains constant with time, this means that the object is at rest and velocity is equal to 0. The slope of this graph suddenly becomes negative. The object is moving back the way it came. Its velocity is negative after time t. If the positive slope suddenly becomes a negative slope, it means that the object has changed direction and is now moving backward. The displacement time graph is curved. This slope is changing. This means object's velocity is changing. This is considered in chapter 2. If we look at the displacement time graph at t is equal to 0, the slope is steep, which means velocity is high, and after a certain amount of time, the slope is less steep, which means that it is moving slower, hence velocity is decreasing with time. Figure 1.9, the slope of a displacement time graph tells us how fast an object is moving. We have considered different cases. Deducing velocity from a displacement time graph. A toy car moves along a straight track. Its displacement at different times is shown in table 1.3. This data can be used to draw a displacement time graph from which we can deduce the car's velocity. At t is equal to 0 second, displacement is 1 meter. At t is equal to 1 second, displacement is 3 meter. At t is equal to 2 second, displacement is equal to 5 meter. At t is equal to 3 second, displacement is equal to 7 meter. At t is equal to 4 second, displacement is equal to 7 meter. At t is equal to 5 second, displacement is equal to 7 meters. Displacement and time data for a toy car. It is useful to look at the data first to see the pattern of the car's movement. In this case, the displacement increases steadily at first, but after 3 seconds it becomes constant. In other words, initially the car is moving at steady velocity, but then it stops. Now, we can plot displacement time graph, figure 1.11. We can see at t is equal to 0 second, displacement is 1 meter. At t is equal to 1 second, displacement is equal to 3 meter. At t is equal to 2 second, displacement is equal to 5 meter. At t is equal to 3 second, displacement is equal to 7 meter. At t is equal to 4 second, displacement is equal to 7 meter. At t is equal to 5 second, displacement is equal to 7 meter. If we study the graph, we see that from t is equal to 0 to t is equal to 3 second, the gradient is constant and velocity is constant. The car is moving at a steady speed. From t is equal to 3 to t is equal to 5 second, the velocity is 0, gradient is 0, and the distance remains constant, which means that the object is at rest. We want to work out the velocity of the car over first 3 seconds. We can do this by working out the gradient of the graph, because velocity is equal to gradient of displacement time graph. We draw a right triangle as shown. To find the car's velocity, we divide the change in displacement by the change in time. This is given by the two sides of the triangle labeled delta S and delta T. If we look at the graph again and we draw a triangle, we see that delta t changes from 0 second to 3 second and delta s changes from 1 meter to 7 meter. Velocity v is equal to change in displacement over time taken. V is equal to delta s over delta t. V is equal to 7 minus 1 over 3 minus 0, which is equal to 6 over 3, which gives us 2 meter per second. Hence the velocity is 2 meter per second. If you are used to finding the gradient of the graph, you may be able to reduce the number of steps in this calculation. Thank you for watching. Allah Hafiz.